bring up the cluster, so cluster, and then bring up the OHS and test it. Means only the testing is something that we wanted to do, but there's no point in just doing a session for that. We'll be doing it parallel, right? Testing of OHS for a cluster. Yesterday we already tested it with EM Enterprise Manager link, so we know the OHS is working. Means OHS and the proxy plugin configuration was working. Means we were able to route a request to the Enterprise Manager EM console from OHS. So what we thought was we will do it for the entire cluster also, but we'll do that one later, or parallelly in some of the sessions. What we'll see today is OSB. Now this again, OSB is again from an integration perspective we are looking at. The reason why I have included this one is most of the environments, or at least many of the environments where you have SOA, also seems to be having OSB. So OSB administration itself is a separate element or a separate profile. That's another full-fledged profile, but from an SOA perspective, we would like to know what's the general structure of OSB and how do usually things get integrated between OSB and SOA. So before we go into the structure of OSB itself, the first things first, OSB is usually in front of SOA. So let me give you an overview of how OSB looks like at the location of the OSB. Let's say this is SOA, right? Your SOA infrastructure. Let's say these two are a couple of SOA servers. SOA infra 1, SOA infra for source 1, let's say. And then SOA infra for source 2. We can put them into a cluster. Now this SOA infra, we know it has composites which are exposed as services outside. So there's a WSDL and there is a WSDL here. And to contact the SOA infrastructure itself, probably you have OHS if there is a direct invocation or a callback. Now, let's say here there is a front-end application. I'm giving one of a sample architecture. This, let's say, is a front-end application, a browser. Means the user is accessing some website kind of thing, right? Something like http mywebsite.com. mywebsite.com. And this happens, let's say they land on some load balancer and then they come to WebLogic. So this is a WebLogic server, let's say. This is a regular WebLogic app server with Java application. General. Now assume this has its own database. This has nothing to do with SOA. Now when a user accesses the WebLogic application, so they will get a page of my website, and anything that they do on it will be handled by WebLogic. And let's say some of the tables in this are getting updated from a database perspective. Now whereas this SOA infra has its own database, guys. SOA infra, our dehydration store is different. So here SOA infra has its own database with its MDS. So this is different. So what we are looking at is, let's say we have a simple structure wherein a website gets used by an external user, or let's say there's a large company like GE where all the internal employees are using a lot of applications. Those applications are deployed to Java and then they're accessed in let's say in the browser. Now when that happens, every time somebody updates or somebody accesses application does something, let's say a table is getting updated. Here a table is getting updated. Now this table update is what we are calling an event. What we are saying is this table update is what we are calling an event. So here when this event occurs, right, now in between, now you can actually set up it in such a way that this event will result in SOA infra kicking off an instance. That's one way, using some DB poller kind of thing. You might have a database poller which is monitoring this table. Alright, whenever this table gets updated, automatically the composite kicks in. That's possible. Means if the composite has subscribed to these events. Another thing usually that happens is in between the front end and the SOA infra, you will put usually what's called the OSB. This is another way usually. Now what happens here is OSB gives certain features that can be used or that can actually hide the backend. This is the OSB that we are looking at. As we move into further this session, you will understand what kind of features that OSB provides, that that we are going to place it here. Probably at this point you may not really understand why we are placing OSB here, but as we move into this session, you will see why is OSB required in front of SOA. Now normally the reason why we are putting it here is we want to hide the WSDLs that are the services that are on the backend. Let's say tomorrow we want to replace the entire WSDL URL with something else. We are not using that, the WSDL URL has completely changed. In that case, this application should not have any impact, or some other client. Let's say there is another .NET client here, a .NET client which is invoking a WSDL should not get impacted directly because this WSDL on the backend has changed. So this OSB basically provides a filtering mechanism to hide the backend. And this is when external users they access OSB directly. OSB chooses to invoke a backend service. We'll come back to the structure of the OSB and why that structure is required in a moment. Alright, so what we are looking at is we looked at two different scenarios here. One is a front-end application where things are getting done, a database is getting updated. Based on the database updates, instances are getting created in SOA infra, but the instances are getting created through an OSB. Means OSB itself has a DB polar kind of thing in that case. Another scenario we have seen, we are discussing, is a .NET application or a Java application which invokes a service, but the service that it is invoking is at the OSB level. It's not directly invoking a SOA infra level service. Now the idea here is a .NET application going through OSB is, if we want to change the backend, it should not impact the front end at all. Means the .NET application need not have to do any changes to the code, or need not know about the change at all. So the purpose here is OSB basically hides the backend, especially the SOA. Alright, so it's called in technical words virtualization, service virtualization. You're making the backend service virtual. The client is not directly accessing the backend service. They're accessing through an OSB. OSB practically hides the backend. Let me go further into this discussion. You will understand in a better way. So let's see this. This is a general structure of the location of OSB. Basically, it virtualizes any services. It sits in front of the end user. This diagram is not really that helpful. It gives you another confusion here. Why is this is SOA? In SOA, behind SOA you have Oracle SOA. Between SOA and other services you have, see this one, this is events. Between events and SOA is where Oracle service bus is. This is what we talked about. Look at this one, this is partners. Partners access SOA through OSB. So the flow is basically from behind, like this. This is where, like this. These are partners, let's say external users. They access OSB. OSB takes you to the SOA. The same way events occur. Events will trigger service calls in OSB, which will call SOA. But as these things are not that much clear. So this diagram, this is the kind of diagram we will see in most of the documents everywhere, but this is basically not a correct one. The one that we have seen is probably, it makes much more sense. So here, coming back to OSB, let's see why you need OSB, or how is it different from SOA. Because you already have SOA, which is providing a WSDL exposing a service. Now why do you need OSB to expose the service? Or why do you need WSDL? Why do you need OSB to hide SOA? Let's see the differences between SOA and OSB briefly, then this is what we'll be talking about. Now the main thing that SOA provides is service orchestration, or the process orchestration. Means from an end to end, the business process will go like a series of service calls, like the one that we always talk, the eBay flow. When somebody makes a purchase, that's an event. The event triggers an instance. The instance goes on till the feedback is received. Instance to delivery, delivery to tracking, tracking to then feedback. Now that long running instance or the controlled instance flow is provided by a process called BPEL process, and the controlling itself is called orchestration. So SOA infrastructure basically provides you the ability to execute an end-to-end process in an instance. Then obviously there are long running process in SOA. Then you have, this is a very important thing, that it allows you to interact a manual interaction into a live workflow. See, the instance is a live workflow. In the live workflow, you are allowed a manual intervention or manual correction. Something like, let's say when there is a fault, when the fault occurs, it can be sent to a human workflow, it can be corrected, and the instance can be continued from that point. So SOA basically allows a manual intervention also. Then there are decision services which will allow the definitions of business rules, and the business rules can be changed dynamically. Means while the business, let's say today the discount is 10%, tomorrow is discount is 20%, those kind of rules can be implemented directly into the system without making any changes to the code. And then we got sensors inside a composite code that will tell us what is the exact location of the business transaction. Means exact location of the instance. When the instance is flowing through, we know the location of, means exactly at what point the instance is by putting certain what are called sensors inside the composite. These are some of the features of SOA, especially the one is it's an orchestration engine. It allows human workflow. These are the two important things. Now, as opposed to SOA, so obviously when we deploy a composite to this one, the composite is exposed as a service outside, and anybody who has a WSDL of this service can contact this service. Now when comparing this SOA to OSB, OSB provides certain other features. We're going to see these features. Dynamic routing, service pooling, message throttling, result sets caching. We'll see what these are, all these things, and SLA alert rules. Now these are the features provided by OSB that are not available in SOA. SOA is basically the engine where things get executed. But before somebody wants to execute it, there will be a lot of other issues like network outages, like not knowing whether which service to call, the service itself not being available. Those things are actually taken care in OSB. Means OSB ensures that a request by a client reaches safely to an SOA environment. Now let's see how it does it. Take for example the first thing, dynamic routing. Now before we go in there, let's just look at the architecture of OSB. This is basically the architecture. OSB has a very simple architecture, guys. This is your external service, which is on the left side. It's most likely an SOA infra. Now this is where a composite is deployed, and a WSDL for that composite is available. And in front of SOA infrastructure, you have OSB. This is your OSB. Alright. OSB has two components. One is proxy service, other one is business service. It's a very simple one. Proxy service and then a business service, which is this. Proxy service is the front end. That's what the end user calls. Business service is the back end. That's what the proxy service calls. And business service is usually linked to external service here. So here if you say the business service gets linked to the external service, means you have a server infra. The server infra is linked to the business service part, a backend of OSB, and in the front end, customers invoke a proxy service. Now that also has a WSDL. The WSDL is actually given to the customer. Now when a customer invokes a proxy service, the proxy service may do certain things.
Anil?
Yes.
Sir, hello.
Yeah.
A quick question. Like, if somebody gets hold of the WSDL, like, can they bypass this proxy service? Can they go directly to the SOA infra?
Yes, they can.
Okay. Is there any way we can prevent it?
You put some kind of authentication mechanism on that WSDL of SOA.
Okay.
And don't reveal it. And that authentication will be available only in this OSB. Means OSB will be able to authenticate itself, but external users cannot.
You mean in terms of like a certificate?
Anything possible. You can put a username password to the service, or you can put a certificate.
Okay.
Just like a web page, you can protect it. This web service here that SOA Infra has, you can put a username password to that one.
Oh, okay. We can do that. Okay.
Yes, we can do that.
Okay. So that so the same when we call the service from proxy, so the proxy has both the user ID password?
Yeah, the business service has both the user ID password. Proxy calls business. Business is the one that calls external service. So when we are configuring the business service and the external service link, we need to provide that username password.
Okay. Yeah, thanks.
Okay, so coming back, the front end is a proxy service. That's what the end users will call, and the back end is a business service which gets linked to the external service, usually SOA Infra. Now, the business service can link to many of the services on the back end. You may have a lot of other services, not necessarily SOA. Alright, or you may have a lot of SOA. Alright, and depending on the inputs of the message the client has given, you may want to connect to different services on the back end. That decision will be made by the business service depending on the content of the input. So here it's possible that you do certain types of transformations or make some decisions in OSB, and depending on the decision you call one of the services deployed to SOA. So here the pipeline that you are seeing here basically does that decision making or transformation to the masses. The proxy service is the front end. The customer will give inputs to the proxy service, alright, and input message, XML message. Based on the XML message, the pipeline may change the contents of the XML messages. It may add certain things, it may strip certain other things, it may correct certain things. Alright, after it's done, the business service receives that content. The business service may put certain rules on the content, and looking at the content style, content properties, it may call one of the several backend services available. Now the question, let's say it's a very simple thing. For example, let's say you are applying for a loan, and the front end application to apply for a loan is let's say a web page or something, but all regions, two different regions are there. Region 1 should go to one service which is available here, let's say. Region 2 should go to another. SOA infra. Now in that case, we cannot say it in the front end that region 1 users fill one form, region 2 users fill another form. Instead, you give a common form to the front end users. In that ask for the region, they invoke the proxy service. The proxy service invokes the business service. Business service looks at the region property. Depending on the region property, it may invoke one service or the other service. So proxy service, business service basically provide certain transformation to the messages. Means between proxy is the one that receives everything, and business. Let me redraw this diagram a little bit more.
Can you put that example as like a can you put that example as like a loan, and probably if he's asking like 100K or above, having credit rating. So one service goes and checks your credit rating, and other one goes for the loan amount that you are asking. So the message transformations or message massaging gets done on the OSB, and depending on that, it goes and kicks the business service. Something like that.
It can be done.
Am I close to?
It can be done, but that sounds more like a SOA work, isn't it? A composites work. But that can be done. Means depending on the loan amount, you want to invoke either service 1 or service 2, isn't it? That's what you want to do. So if this amount is more than 100K, you want to invoke service 1. If the amount is less than 100K, you want to invoke another service. That can be done, yes. That's possible. That's structure.
I mean, one web page will have your social security, your credit card information, blah blah blah. And other information will be like your loan information, which location you're asking, blah blah blah, and all that, and the bank that you are trying to apply. And so your credit rating will give like one info that goes to a different that goes and invokes another external service. It could be something from the federal, or it could be something from your end as well. And the loan is personally dependent on the bank. So once you get the credit rating on based on like those range and your loan range, then you can kick off your external services. Is that something for that we use OSB or something else?
It can be. The case that you put in place, it can, an OSB can use, can be used. It can be done.
Okay.
But usually the credit rating thing, that thing, it gets done inside
I'm just
the
giving
composites itself. Yes, yeah, but it can be done, yes. Okay, let me now redraw this diagram a little differently. Any other examples for OSB? OSB usually, is used for a different purpose than what we were discussing so far. We'll come to those things. Why we use actually OSB. Let's go ahead into a little bit more into it. It's not actually for process orchestration. Means the loan execution that we're given, we don't use the conditional checks and everything probably in OSB. OSB is more for generic purpose things. What we have just discussed can be done in OSB definitely, but it's more like the process itself, and we are trying to execute part of the process in OSB. We may not want to do that. That will actually cause problems if we change the backend and try to put some other thing in place of existing SOA service. We'll come to that one. The exact details you will understand it in a few minutes. So here, let me come back to this one. So you have a OSB, the front end proxy, and the back end business service. The business service is the one that's linked to the external services, and the proxy service is what gets called by a client. Now between proxy service and business service there are pipelines. So if you see this one, so this is OSB, let's say, right? Then you have a proxy service which is front end, then there is a business service which is back end. All right, between these proxy and business service, this is business service. Between the proxy and business service we have what's called a pipeline. Now the pipeline is actually for message transformation or changes to the message or any processing that you do between proxy and business service. Now the business service may call a lot of other things. Means depending on the contents of the message, the business service may call service 1, service 2, service 3, like that. So any service like this. Like this, it may call anything. Alright, so this is the general structure of OSB. OSB is a pretty simple structure. Now, why we use such a structure is, the first thing we said is for message throttling or service pooling. Let's see what that is. Let's go back here. Just we said agility. Basically agility is because of, instead of the consumer or the client directly calling the service provider, we are putting the consumer and the provider at two different ends, and in between you are providing OSB. Now this is a summary of reasons why you want to implement OSB. Is a summary, like supports different message formats. For example, the provider may be supporting only one format, but the consumer may not be giving it in that format. So OSB can be used to transform that format. Let's say the consumer is providing an XML format and also a text format or an Excel form. So whatever the consumer is giving the information in, let's say you can fill up a form, or you can send an XML file, or you can send an Excel file with all the inputs. But the service provider takes only XML. In that case, the inputs that are coming from the consumer need to be converted into the XML. Now that can be done using OSB. Now the endpoint can be moved. Endpoints means this thing, the service providers can be moved. You can replace the service provider with a new one without impacting the customer. Service versioning, you can give a lot of versions to the service. Then availability and scalability means multiple service providers can be here, and depending on who is available, you can call the corresponding service instead of consumer worrying about non-availability of service provider. And security is obviously because you are not exposing the service provider directly to the consumer. These are some of the generic points, but going into specifics, let's look at the first thing, dynamic routing. What dynamic routing does is, this thing. Let's say when you are designing or developing the service, or not even developing the service, let's say you have two services on the backend. All right, assume they both are deployed so infra, or wherever they are. There are multiple services. Depending on the contents of the message, you can dynamically route the request to either service 1 or service 2. This is what we were talking about so far. So you are dynamically invoking different business services depending on the content. Now these services may not be known at the time of development. Means when we are designing a solution, we don't know that we require such a service. because and later, at a later point of time, we realized okay, we might need such a service, or we divided a complex service into multiple small services. That way, to modularize your overall environment. Now, any such changes should not directly impact the front end. Means, let's say a large complex service you have divided into sub-services. Earlier, the customer was calling the complex service directly. Now you're asking the customer to do a lot of, you're giving a big form to fill with 4 or 5 pages to fill it, and based on that form inputs you are doing a routing. Instead of that, you can use OSB in front, practically hide everything that is happening on the backend. You can change anything that's happening on the backend. It will not have any impact on the customer. So the OSB basically hides in that case. Means the dynamic routing provides, based on the inputs, you either call service 1 or call service 2. You can replace service 1, service 2 directly whenever you need to. That's one feature that OSB provides. Means by hiding the backend, it gives you a little more flexibility on the changes to the backend. The second thing is service pooling. Service pooling is especially to handle network delays or network interruptions. For example, let's say the external service is not available for some time, for whatever reasons, or there are intermittent problems in accessing the external service. Now, if the end user is directly accessing the external service, which is having issues, sometimes the end user will be able to access the external service, other times they won't be able to. Instead of that, if we can put OSB in place, OSB provides that buffering mechanism. So what happens here is, if you see the service pooling, it calls for the first time. The business service calls an external service first time. The external service is not available at that point. It calls again after 2 seconds. That also not available. It calls again after 2 seconds. Like that, you do it 5 times. Now that kind of configuration can be done in OSB. Now if you don't have OSB, obviously the end user request invocation is going to have failures. Remember one thing, the end user is not always a person. It can be an application also. So there may be another application that you have which is invoking this OSB. Now that if this feature is not available, and if the end user application is directly invoking the external service without OSB, if the external service is not available, the front-end application doesn't know what to do. Or you need to code the front-end application in such a way that if the external application is not available, or if the external service is not available, retry it after some time. That kind of coding needs to be done in the front-end or calling application. But by putting OSB, you can virtually guarantee that even if the external service is not available, the call will still be taken, because the OSB is the one that is actually doing the retrace. The front-end application does not really know about the small interruptions. We are not saying that if the external application is completely down, OSB is going to take care of it. It cannot. But in case of small delays, that cannot, the small delays cannot be handled by the front-end application. But a OSB has such a provision that if the external application is not available, wait for some time, try it again, do it a couple of times, 5, 6 times like that, and see if the external service is available. This is only for intermittent problems or small interruptions kind of thing. So that kind of service pooling is available in OSB. So we are looking at dynamic routing and service pooling. There's a second feature why you want OSB in front of an external service. Now the service pooling is another way also. Let's say here This gives you a better idea of service pooling. Again, let's say one service is available. You have multiple services, means any of them you can call. That's what the kind of setup you have. You can call instance 1, instance 2, instance 3 depending on availability, or you want to load balance across all these instances. Let's say the number of incoming requests, you want to load balance across instances, means across services. Here I think the instance is a wrong word here, so let's put it service 1. This is not an instance, this is a service, but in the context, if you take, it's still instance 1 of service 1.
Another quick question. Like if we are in a cluster, then it is called instance, right? If there are two instances in a cluster, basically they are called two instances.
They're so infras basically, but yeah, we call them based on context. We understand that what we are actually saying. When we say instance in a strict word, we always mean by when we invoke a composite, an instance gets created. That's what we always say.
Okay, but saying that in this case OSB, like if we have the same composite deployed onto multiple like instances, so is that the case, like business service can load balance between the two instances?
Yeah, that
is
can
that what
be done.
you are referring? Okay.
That can be done, but it's not necessary that we want to always call same one on the back end. Let's say I have service 1, service 2, service 3. Let me give you another example here. I have service 1, service 2, service 3. When a request comes in, I can call any of the backend services. Let's say that's the kind of business setup that I have. It's not necessary that all the 3 services are same here. I have a setup wherein any request that is coming in, we can invoke service 1, service 2, service 3 depending on their availability and the load among those 3. Now in that case also, we can use this OSB service pooling feature. What you said is, basically all the 3 are same. You are load balancing across similar services, but it need not be always the same. Means your business requirement might be like, okay, call any of the available services. They need not be same.
Okay.
So that kind of business requirement may also arise. So you may pool either similar services, like you have a cluster and so infras, you have multiple so infras. All of them have their own WSDLs. Let's say you pool those WSDLs, or else non-related service also you pool and configure it to a business service and try to load balance it depending on the requirement. It's all from the business requirement that we have.
So saying that if it is a different service, then the criteria how it picks up the one service, that can be configured in the business service?
No, this is simple pooling. All that you have is, see this one here, a load balancing algorithm. It says round robin.
Okay.
So the algorithm simply basically goes through the service 1, service 2, service 3. But here we are assuming the business service inputs are accepted by the receiving service and it is capable of processing those inputs. Got it? It need not be same. We have a simple assumption. You have a simple assumption that they all need to be same, but in a true business scenario, they need not be same. There are 3 different processes. You can, let's say randomly you are putting it into one of the services. They may be same, they may not be same.
Okay. Yeah.
So that kind of pooling and a load balancing across multiple services can be configured in a business service. Then the next feature that OSB provides, see, message throttling. Message throttling is especially if you have a burst of invocations, like I said, at a time you're running a program that's a batch script or something that's making too many invocations. Now, when such a batch script is done directly on the service provider, the service provider may not be able to probably get invoked all the time. Let's say you're running a cron job. The cron job basically invokes a service. When you're running a cron job and in that invocation of service, it happens as a burst of activity, means you are invoking the service 1,000 times within probably, let's say, 10 seconds, 20 seconds. It will not be able to basically serve all the invocations. Some of those invocations may fail. In such a case, your script itself should have a mechanism to put in a delay, or else your OSB can do that. In a different, look at a different scenario. Let's say there are a large number of customers. They are all invoking the service provider at a time. Like, let's say 1st of every month, or let's say 31st of every month, there is a closing date, and all the vendors are the ones that are your consumers. All right, all the vendors, they want to invoke, close up all the things on 31st of every month. Probably during the evening times, you may have too many message invocations from the consumer. If you don't have a OSB, you may have failures. So if directly a customer or the consumer application is invoking the server application, you may have a problem. It's like, let's say, Walmart, all stores have to close their numbers, sales numbers or inventory numbers by 31st of every month. Now let's say you have Walmart has a server, and all these stores basically invoke one of these stores have internal application. It's Walmart application. All the stores are using the same application. They all need to submit or close their numbers by 31st of every month. So obviously, across the world, wherever Walmart is, on 31st of every month, there is a huge traffic to Walmart servers, because everybody from every Walmart are updating their data. Now probably during the evening time, the number of calls to that service are huge. Now when such a huge numbers, that is spikes of numbers come in, some of those requests may fail. That's what you will see, like when you're going into a high traffic site, you have to do it repeatedly again and again. For example, if you are in Indian Railways IRCTC site, if you go, it's heavily loaded in the morning at 10 o'clock. That's when the Tatkal gets open. So sometimes you get connected, other times it's not. That's not a SOA environment, but that's an example of SOA kind of thing. So what we're looking at is peaks or bursts of invocations can be handled effectively by using a feature called message buffering. So you buffer the message, you allow it to the service provider in a streamlined fashion. Look at the graph here. The service invocations were like this. There's a spike in the number of invocations, then it's going on like this. So the spike is basically controlled by OSB, and the service provider receives calls in a flat number. Means the OSB basically allows a smooth flow. Look at these parameters here. Throttling is enabled, the maximum 5, and throttling queue is 100. Means in the queue you will be able to store 100 messages, and 5 is at max. You will be calling to the service provider at a time. So that way, the idea is basically the service provider receives not a burst of calls but a smooth flow of incoming requests. So the service provider is not unnecessarily loaded, and on the consumer front you won't see that as invocation has failed. All that probably the consumer will see is it's getting delayed. There is a slight delay in processing the request, but you won't see that there is a failure. That will be usually taken care by the message throttling of OSB. So let's go back and let's move on. And the next feature is read-only calls. For example,
Anil, quick question.
yes.
Quick question. Hello.
Yeah.
Instead of like throttling, can we prevent from just one client? Like instead of throttling every one, say if one client is doing maximum number of trying to connect many times, is there a way we can restrict one client through OSB?
No, I don't think that's possible. We can't.
Okay.
That requires probably another product in front of OSB, a security kind of product that will basically prevent multiple invocations within a certain time. Means there are products that will, let's say, a single IP should not send more than 10 requests per second. That kind of restrictions can be put on, but OSB cannot do it.
Okay. Yep.
Anil, question.
Yes.
The logic side can also configure the threshold of the incoming request, right? Can buffer the incoming request in a queue, right?
You can use a work manager to do that. Yes, you can. You can set up the capacity constraint of a work manager. And work manager.
When you say message, we can configure like quotas or anything else that would help, or is it really required for SOA?
No, you're talking about WebLogic to, okay, so WebLogic part of SOA. No. That's not the way it gets used. The WebLogic gets used in SOA, right? It's not the message that actually triggers every time a composite. Not every message triggers a composite instance. That's one way of triggering an instance.
Okay.
So if you see, let me give you an example. What you said was probably this. I think this is what you have in mind. There is a queue, a WebLogic queue. So, alright, the WebLogic queue is receiving messages, and based each message, when there is a message, alright, it invokes a composite which is deployed here. Now what we are saying is you can actually prevent the number of messages coming into this one, or you can put quotas on this message.
Right.
Yeah. But
just for a message, any incoming request on WebLogic side is a thread, right? So that can be put at that in a queue so that can prevent more number of requests.
Yeah, but the requests are not received by WebLogic, right? Here in our case, in a SOA environment, WebLogic is basically used by SOA. So how an end user is invoking SOA here, they don't have anything to invoke on WebLogic. You need a Java application on WebLogic that probably needs an invocation in that case. Where is this queue? This queue is on this WebLogic. That's what you're saying, right?
Right. Since we configured all those BPL related, SOA related, BPM, UDT, they're all queues, right, on the SOA infra.
But they are for SY, means to run the engines of SY. This is a composite. Let's say this is a WebLogic. This is WebLogic. We are using a lot of queues and topics of WebLogic, but those queues and topics are for SOA itself. What's on your mind is we can have a queue, which is here again, alright, and based on the incoming message of the queue, like this, alright, based on the incoming messages of queue, we are invoking this composite. That can be done.
Right.
There's nothing wrong with it. Then it will basically create instances. That's your idea. Now the question is, how do we put the messages into this queue? You definitely need an application to do that one, isn't it? Which needs
right.
to be accessed by an outside user. Or else you need somewhere or some bridge kind of thing which puts messages into this queue. M1, M2 like that, right? Which invokes the composite or which triggers a composite instance. So this throttling, we can't throttle here in the message. Even let's say your assumption is we go by your assumption. WebLogic allows only message thresholds, means it tells me how many messages I can put. It doesn't basically provide a delay kind of thing. What happens is, let's say if there are 1,000 messages in here, it is still 1,000 invocations on here. The delay is never mentioned. For example, if you see in the features of this one, you see the maximum concurrency that was given here. We are saying only 5 invocations can be done at a time, whereas the architecture that you have given, if there are 1,000 messages, 1,000 invocations happen at a time. You got it? So in a architecture like where you hold the messages into the queue, if there are 1,000 messages, 1,000 concurrent invocations happen, whereas OSB is not allowing that one. Even if there are 1,000 messages, it allows only 5 invocations. That way the provider is not overloaded just because there is a burst of messages coming in. So the feature that we are looking at probably cannot be, it is complicated in WebLogic. Whereas here I think it's much easier. Means whatever you said is already implemented and they are selling it as a product. It's more like that's what they're doing. So the message throttling, again, coming back this one. So what we are looking at is OSB basically reduces the spikes in the input or reduces the spikes in the invocation. It provides a streamlined or a smooth flow of invocations to the service provider. That's message throttling. The next important feature is service result caching. This is especially for read-only services. Means, let's say you are calling something like an external service with stock codes, or probably stock codes is a dynamic one because every time you make a call the price changes. But let's say there are some services which provide let's say credit rating service, the one that we usually talk about. The credit rating service, usually your credit rating doesn't change in a day. So what we have here is, if a credit rating service is being called and if there is a OSB in front of it, because let's say we have a situation where this is read only, we are saying, means the output of this external service is read only, it doesn't change too much. Now what we do is, when the business service calls external service, the result we are storing it in the OSB itself. When there is a similar call next time, we are not going to the external service, we're picking up from the buffer of the OSB. Now again, we can define how long this buffer is valid. If you see here, the duration is given here. The duration says 0 days, 1 hour, means this buffer, the copy in this buffer is valid for 1 hour. And for, let's say, the example that we have given, the credit trading example, I can say it's valid for 1 day or 2 days. Let's say your credit trading changes every 2 days. I don't think it does, but let's say if it changes every 1 or 2 days, we'll say every result that I'm storing in the buffer is valid for 1 day. So that kind of expiration can be defined based on the frequency of changes to this external service. Let's say external service is basically picking up from a database. Let's say item prices. Alright. Again, let's go back to Walmart example. A front-end customer can invoke this external service, which will actually go to the database, alright, and fetch the price and gives it to the front-end user. So let's say this is the Walmart clerk. The Walmart clerk is basically invoking external service, and the external service is going to database. Now assume this database gets updated once in a day, means every midnight this database is getting updated. So obviously we know from today's midnight till next day's midnight, if I make a query of the price of a, let's say an item, let's say a laptop price is not going to change from today night to tomorrow night, because the database is not going to change. The data is not going to change, we know that. So in that case, when a Walmart clerk from one city makes a call, it goes through OSB, the business service makes a call to the external service of the laptop. You store the laptop price in the result cache. Then let's say there is another similar call from a different city. Now you can actually pick up that laptop price from the result cache itself and give it to the client instead of actually invoking the external service. And then you define your expiration time to somewhere around, let's say in a cycle like 24-hour cycle. Your result cache is valid for about 24 hours. So those arrangements you will make sure, you're making sure your data is proper. Or you can say, I think you can reset the result cache at a certain time of the day. That also probably can be done. So what the idea here is, instead of calling the external service again and again, which is a read-only thing, means this is providing basically the same result every time. It's like a static base in terms of HTML and other things. So the external service, the result of the external service is not changing every time. Because it's not changing, there is no point in calling it again and again. Just simply store the result somewhere and pick up from the buffer. Now that buffering result caching mechanism is provided by the OSB. Alright. The next feature is SLA alerts. SLA alerts is basically what's the time it's taking for the external service to respond, or what is the overall time that we are taking to serve the customer, the calling customer, or the calling service. So here, let's say there is a front-end application the front-end application is invoking a proxy service. A proxy does something with the message and it invokes a business service. Let's say business service invokes an external service. Now this entire process, this is obviously an SLA, isn't it? Like this entire thing should finish in 5 seconds, the end-to-end flow. Now if there is a breach on the SLA, you can set up an alert message. The SLAs can be on a lot of things. What's the minimum response time we are getting? What's the max response time? How many messages are there? Like what's the error count? Let's say out of 100 invocations, 20 are failing. 20% failure rate you have. Let's say that's your SLA. You cannot have more than 20% failures. Then you can set up a rule, and whenever there is a breach, you will have an alert message. So basically it's services type SLA, means when how a service is responding, whether it's responding within a timing or not, how many invocations are failing, how many invocations are going through smoothly. All that kind of metrics can be monitored, and on those metrics you can obviously put rules that will tell the that will trigger alerts. Right, those are the features, guys. Now did you understand why we need OSB when you have SOA? Let me just summarize one more time. This is obviously for service virtualization. This is a keyword here for OSB. Means you're hiding the provider. Now why you want to hide the provider is for a lot of reasons. One is you want it to dynamically route without letting the consumer know about the provider. You want it to be able to route it based on the content of the message, based on the availability of the external service. You want it to be able to change the external service without impacting the consumer application. Then service pooling means basically the network interruptions, small delays that you want to be able to take care without impacting the consuming application. The same way service pooling, that's what we are talking about. Multiple services you have, you want it to be able to call any of them depending on their availability. You can put a load balancing algorithm or a weight based algorithm, anything you want. Message throttling, basically to streamline the number of invocations to the service provider. And then service result caching, especially for read-only services. Then SLA rules to set up how fast your service is responding. So that's your OSB, means why you want to use OSB. These are basically I see that these are pretty strong reasons why you would want OSB in front of SOA. Agreed? Are any questions? Now you understand why you need OSB in front of SOA. Guys, I need some answers.
How about OWSM? Oracle
do we have a
what?
What's it?
OWSM, Oracle Service Manager.
That is for security. Let's say you want to put a username password on this service. That's when you go with the OWSM. We will see that one. We will see when we are talking about OWSM. We will see the basics of OWSM. But OWSM is for security. The realms you have in WebLogic is actually on top of realms you have OWSM, which basically provides security to services. Normally when we are all working on WebLogic, we are providing security to Java applications, right? Here we have services, means we want to provide a security to service. Means let's say you want to set up a username password to a service. Whenever somebody calls a service, they should supply a username password. Now when they supply, that username password has to be validated by somebody. That's your service manager, OWSM. Oracle Web Services Manager handles security for services.
Okay.
Anil, this OSB has to be in the same domain, or it could be in the has to be in a different domain?
It should be in a different domain. Theoretically, it can be in the same domain. Just like SOA we deployed on top of WebLogic, OSB is also a WebLogic domain. That's it.
Okay.
Now the question is, you can use the same domain, or preferably you would like to use a different domain.
Okay. And saying if that is OSB has its own console where you go
Yes,
and
yes. There is a SB console thing. It's there. We will be configuring those parameters also. We will see the integration also. We'll see the installation, integration, everything we are going to see.
Okay. Yeah.
I think SOA also uses its own schema, right? Not SOA, OSB.
OSB, if you have OWSM, it requires a schema. If you don't want OWSM, there is a reporting thing also there. If you want the reporting features, then you will require a database to store those reporting statistics. That's when you use a schema. But schema is not mandatory. Means there are certain features that require a schema. If you don't want those features, you can still implement OSB without a schema, especially OWSM and reporting.
Okay.
You can choose not to put OWSM on OSB, then you don't need a schema. We are going to deploy it without a schema in our environment. We will see that one. Yes.
We have a load balancing mechanism in SOA also, right? So why we need again here? I mean, we can load balance there based on the
using OHS.
Using the cluster. No, SOA we have load balancing, right, with the cluster.
Yeah, we are doing it using OHS.
Yeah, but here also it's required. I mean, if you use both, we should
that
use
that
load
can
balancing.
not necessarily that can be used, or this can be used. Let's say here what you are saying is the load balancing. Let me take to the load balancing. This is what you are saying. So you're basically saying you have a SOA cluster, and in front of SOA cluster you have a OHS. Alright, the OHS is actually taking care of dividing between the instances. Now your point is, let's directly invoke, let the business service directly invoke OHS like we did yesterday. That can be done, no issues with it. But let's say the services on the back end, either they are not clustered or you don't want to implement OHS. Let's say you don't want OHS, you simply have a cluster. So infra 1, so infra 2, there are two SOA infras. You directly want to configure them into business service without implementing OHS. Is that possible? Can we do that?
Yeah.
We can, right? Yeah. So we are basically, you're removing OHS, an additional burden. You don't want it. Let's say you just remove OHS and configure SOA infra 1, SOA infra 2 into business service, assuming you already have OSB for other purposes. Otherwise, this structure which you have already, this also can be used. And there is another reason why probably you want to use it. Let's say this is not a clustered setup. Means it's not necessary that all the instances need to be same. You have like this instance 1, service 1, service 2, service 3. When there is a request, you can call any of the services. They're all 3 different services. They're not clustered. But your business mandates that you can invoke service 1, you can invoke service 2, or you can invoke service 3 when there is a request. In that case, these are neither clustered, they are not same. They are 3 different services, but all that you want is, you want to divide the requests among the 3. In that case, you will directly put a service pooling mechanism between business service and the external service.
Okay.
Okay. Any other questions, guys?
Make things clear, like you are saying there is no need for a OHS? Like when the client connection comes, like
Yeah, OHS is required when you have a cluster and you want to access the cluster as if it's a single unit.
Okay.
That's it, right? You don't want to access two different URLs. That's the point of OHS over there.
Yeah.
But if you don't mind accessing these two SOA infras as two different URLs, you don't need OHS. And in the business service, you can configure both those SOA infras because this is internal. The front user, the front end consumer is still receiving only one WSDL. The business front, what's that?
On the SOA, you can configure the front end host.
On the SOA, we have a cluster on SOA. That's a case here. And instead of putting a OHS in front of cluster, we are simply taking the two instances of a cluster and putting those two instances in business service directly.
So Anil, so basically here, like if the business needs that OSB should be used, then in that case, so we don't need to use the OHS, right?
That's right. That's correct.
Okay. Okay.
Any other questions, guys? Okay, if there are no other questions, we'll stop it here for today. Tomorrow we'll see the installation of OSB and integration with SOA. And basically, configuring this proxy service, business service. We'll see a very basic OSB structure and creation of elements in OSB. And then we'll integrate one of the services that is deployed to our SOA with OSB. Alright, any questions?
How many sessions remaining now?
We got one for OSB, then one for purging, performance tuning, and administration, and OWSM1, 3 at max.
Anil, this is Dinesh.
Yes, Dinesh.
Anil, remember yesterday I sent you a mail regarding that videos. So I've downloaded again from a different laptop and I've tried. Even the sizes of the videos are very low, like 18 MBs and 30 MBs I see. So I guess there should be a problem that had happened while encrypting. Can you just check it once again?
Sizes are low. Okay, I think there could be a problem. I'll check it out.
Yes.
I'll check it out, yeah.
Even for me the same only. It's 30 MB something thing.
Because from day 8 I face issues. From day 8 videos are not proper.
Okay, let me check it. I think there might be an issue on the server. If you're saying the size is low, then there could be a problem. I'll check the sizes and I'll check it out one more time on the server.
Fine, Anil. From day 8 to day 13 there are issues with the videos.
Yeah, the list that you have given me, that one, right?
Yeah, that's right.
Okay,
yeah,
I'll
I've sent it.
Yeah, sure. I'll check everything on that video list.
Okay, it'll be fine if you can send it today.
Yeah,
So I'm just
sure,
planning to follow up the sub classes.
Definitely, sure. Let's try to
Yeah,
do it.
thanks, Anil.
Yeah.
Yeah.
Anything else, guys? Otherwise, you can drop off. I'll see you in the morning tomorrow.
Anil,
Yes.
regarding the issue I had, anyway, I fixed one of, is that okay if I talk you quickly?
Yeah, go ahead.
Yeah, regarding that, what you call the WSM issue, that SOA Oracle Home or whatever, that
Right.
one.
Uh-huh.
I try to put in like in the domain environment, and somehow it was overwriting. But finally, what I did is I put it in the like the JVM parameters.
Okay, cool.
That is how I got it, and it was working.
Okay.
But on top of it, like there is a the second error still coming. But I looked on the Metalink, and I'm not sure whether they say you can ignore for another product. It's not for the SOA, but for AIA I think for the in the AIA framework. They said that error could be ignored.
Okay.
So I don't know where. Just I'll check again with that. But so saying coming back, like the JVM parameters, like those variables are configured for the complete system, or like just I put it into the like I did the put the
You put it under
SOA
Java options, right? I think
Java
that's
options.
what you have added, is it? If you have added it in Java options, and there is only one Java options in set down env, or individual Java options for all the managers?
There are a bunch of them, like -d. There is a string there.
No,
with
not like that. Is it based on server name or only Java options? That's it. No specific server.
Like it is in the domain settings.
Okay, I think it will impact everything in that case. You don't have individual manage. Your managed server JVMs, the sizes, heap sizes are different or same?
The heap sizes they are different.
Means there is somewhere it's picking up. In that case, the Java options that it is using, it is common for all servers. Did you check that PS-EF and grep for Java and see this option being available everywhere? Because you are putting a -d, right? So it should be available.
-d, yes, yeah, like -d within the parenthesis I gave that soa.oracle.home.
Then you will be able to see it on PS-EF grep Java.
Okay, I know. I saw that one in the once I did that, I could see in the the log file.
Okay.
In the log file, I can see those there.
Okay, cool. Now just to confirm that whether on one server or all the servers are getting impacted, I am assuming all the servers are impacted because you have put it only at one location Java options. But now double confirm it. You can do a PS-EF grep on the servers. Alright, look at admin server, see if that parameter is there. Look at manage server, PS-EF, and then see if that parameter is there.
Okay.
So that will confirm that parameter is across all the servers.
All this, okay. Yeah. Okay then. Thanks.
Okay.
Thanks.
Any other questions, guys? Okay. I think I'll drop off for today. Thanks very much, guys. I'll see you tomorrow. Yep.
Anil, day8.exe is also not there, Anil.
Yeah, that's what Dinesh was also telling. I think the exe, day8 exe, I'm not sure why day8 exe is not there. Just let me see. Something is going wrong with the server. Yes.
All this we can play 10 times, right? Maximum.
You can play 10 times. If you're exhausted, you can ask me. I'll give you 1 more time and 10 more times. That's the restriction is not for you guys. It's basically if outsiders cannot grab my videos. You need more times, just let me know. I'll give you more times. That's not a problem.
Okay, fine.
Day8, you said day8 doesn't have exe, is it?
Yeah.
Day8 DTXE, this is the one I can see it here.
Anil, this you have uploaded yesterday. If you see day 9 for BAM exe, it is not there.
Yeah, day 9 BAM is how come day 9 BAM is not there? Oh, BAM is not there. Okay, we have a problem with BAM. That's why I have uploaded these things. BAM 2, BAM 2. We had a problem with BAM recording. This should be a 0 bytes file. What happened was on the BAM day that we did, nothing was recorded. It was 0 bytes. So what I did was I actually uploaded the recordings of previous batch. I put it in the mail also. I think you guys have missed it. So all that I have to do is remove this ppvm file. That will fix the BAM thing. Means you will be able to see this BAM thing for the last batch. Our batch discussion you won't probably find it. That's not recorded. Means the button was pressed, but for some reason it's not. I think there is a